Welcome to the future.
Welcome to the Muxall Open IoT channel. I am your host, Michael Crane. Okay, so it's about 3:30 in the morning here, November 15th on a Friday. Friday morning, that is. and we are going to be doing some probe testing. I promised the manufacturers I'd have them some data today. Actually, I think I promised I'd have it to them on Thursday, but this will be close enough. I'm sure they'll be happy one way or the other. Now that I know that the oven has a lot of temperature gradients in it, and that the middle of the oven was much hotter than where I have the temperature probe, I figured out a new profile on the computer, which I'll show you here in a minute. And it's I didn't bother trying to move the probe around. I just adjusted the temperatures for where the probe is at, and you'll be surprised. Of course, the probe does. The RTD is inside a metal tube that so the metal tube has to heat up the RTD. So you get a little bit of a thermal lag there. The fluke is much faster at reading. But it won't go as high as in temperature as RTD, so we can't do these tests for very long. The fluke insulation on its thermocouple is Teflon as well. So if I damage the probe, I'm going to be damaging the fluke, and we don't want to do that. So we're just going to test up to what we've been reflowing at, which is around 430, 450 degrees, but not for very long, just for 10, 20 seconds or something like that. Okay. Yeah. So the setup is I have the probe inside there. This is the one we damaged the other day, and I'm just gonna make sure that this plastic coating is gonna be okay. I'm sure it is. This isn't plastic. I'm sure this is some kind of Teflon, because as hot as I cooked it the other day, I'm guessing that it's probably it survived pretty good. And of course, these wires are coated in Teflon. They also kind of got cooked. And we're still going to take a closer look at this wiring. That's pretty bizarre. So, so what I have is I have the fluke probe stuck down inside this pan right here. And I was trying to get it to touch the pan, but I guess as long as it's on the wire or touching something, I want to know how hot the probe is getting, so we know for sure. And so I'm going to go ahead and push this back in here and make sure the pan isn't touching the oven probe in the back there. And shut the door. Okay. Now let's jump over to the PC real quick. Okay, so I'm going to get ready to start the test. Got the camera on the... And I'm at the PC, got the camera on. Let's go ahead and just turn this guy on. This is going to be a very short test, so I'm just going to leave the camera running. Go ahead and add the graph so we can watch it. Huh. Well, we didn't quite reach our target temperature, and my guess is where I have the fluke. It's no longer in the middle of the oven. It's now closer to the door. So, okay. Well, I'm sure everything survived. Let me turn this thing off. Okay. Alright, I'm going to just go back over the camera. Okay. Open this guy up. Yeah, this thing is having no problems now. It still feels hard, doesn't feel tacky, and it shouldn't. Teflon starts having problems at, I think, 380 or something like that. And yeah, this isn't having any problems at all. And I guess we'll just go ahead and throw another probe on there, so I'll be right back. Okay, so we've got this probe here. It's by Hain, and I just kind of have it thrown in there. Yeah, I was looking at our tests, so the way this thing is coiled up, it's going to be all around the edges of the pan. But I'm going to still try to measure towards the center just to make sure that at least some part of the oven is getting close to where our target is. Yeah, I'm just about ready to solder that thing in there. It just won't stay. Now maybe it'll stay. I think that's good. Alright, let's go back over to the PC. We'll fire this guy up and let it rip. Okay, so we're back over here at the PC. I'm just going to come down here to the control, hit on. Alright, go up here to the graph, we'll clear this out, refresh. Clear just clears the data out, refresh, we'll set the cursor back to 0, in case you're wondering. Okay, and this might cook a little bit hotter just because of it doesn't have to heat the oven up again, but it should, from what my experience with it, it should, they should all be about the same, especially when you start getting up to the higher temperatures, because this oven has 0 insulation in it, so it loses heat pretty fast when it gets hot. Yeah, so this first stage right here, this first profile is the warm-up stage, and so you'll see the oven or the controller will actually throttle back the oven, and until it reaches the 2-minute mark at its set temperature. So that's why I'm saying I even with a warm oven, it shouldn't make any difference as far as the max temperature goes. Or it should make it only make a little bit of a difference. Let me say that. Well, that is bizarre. So even with the probe in the middle, we're still not getting to 300, and with the PCB in there, we're shooting well over 300. That's very interesting. And I'm looking at the temperature on the fluke, by the way. Okay, I think it's going to the second profile yet. goes. Well, once again, we did not get to 400 degrees or above it. Okay, well, let me turn this off because it's not going to get any hotter. I do smell a little bit of plastic burning. It's probably the plastic ends on that wire. I don't believe they were Teflon. I just didn't feel like cutting them off. Okay, so let's open this up, take a look at it. Yeah, see these little plastic ends here probably, yeah, see, they're melting together. Whoops. Come on, get off there. I'll cut them off. I should have done that anyway. Okay. Okay, here we go. So, yeah, so the probe, uh-oh. Yeah, so this is supposed to be, I don't know if you can see it, and we didn't even get to 400. You can see this thing right, this piece right here. It's supposed to be baked enamel, or yeah, I think baked enamel, kind of like what you have your pot and pan handles made out of, right? Some kind of, I don't think baked enamel is the right term, but some kind of baked plastic. Anyway, it's supposed to be high temp plastic, and as you can see, that is not going to fly. That is melting, and it didn't even hit 400 degrees, so that's a fail right there. The Teflon coating and the Teflon wire seem to be okay, so that's good. But yep, and that is going to be inside the barbecue, so that's just a complete fail right there. That won't work. So, okay, on to the next one. Okay, got another probe stuck in there. I'm just going to go ahead and move forward with it. We'll know if it melts any plastic. We've definitely seen that. So I think the test is valid. Actually, this thing hasn't really cooled down yet, so it's still on its shutdown cycle, so we'll just let it cool off a little bit more. I'll be back. So, while the reflow oven's cooling off, I took a couple pictures of this one probe that, that we smoked. And this is the probe that, when we were doing the boiling test and the freezing water test, seemed to always be like a degree off. And then after we smoked it, of course it burnt all the heat shrink off, and it loosened this. This is some kind of fiberglass heat shrink tape stuff. I don't know, but anyway, I was able to pull it back easy enough. And as you can see, so here's the two end wires, right, for the 4-wire probe, and then right here they stripped the wire and twisted them together. And I'm just scratching my head why they would do that. And the only thing I can think of is, let me pull up the, come on, there it is. Okay, so so this is supposed to be the wiring diagram, right? Red, red, white, white. And I'm pretty sure I got this from these guys here. I'm not exactly sure. It's not actually in their folder. I don't remember where I got this wiring diagram from. But so where these are supposed to be tied together is right at the RTD. All right. And I'm wondering if maybe someone got confused and thought they should be tied together, you know, down here at the end, because it kind of looks like that. They're probably thinking, man, this doesn't make any sense, but that's the way the drawing goes. So anyway, I don't know. I'm just kind of guessing, but I'm going to strip the other ones back to make sure they're actually wired correctly, and maybe I'll take some pictures of that. Anyway, I just wanted to show you that this is the one probe that we were having problems with. It was like, well, problems, but it was like a degree off all the time, and I couldn't really figure out why. And I kind of like this probe. This is the one that it's got a real nice Teflon coated stainless steel braid, and the probe itself was pretty nice. Yeah, so here's the. So yeah, it's pretty nice. It's just yeah, right here where the heat shrink was is where where we're looking at, right? Anyway, just wanted to show you that. All right, that one's cooled off a bit, and okay, let's go fire this guy up. Okay, back here at the PC, we're going to be testing the Yi Chun probe, and go ahead and just fire this guy up. Okay. Okay, well, it looks like it's peaked out again, and go take a look at it. I'll go ahead and turn this guy off. I guess I could let it sit there and cook, but I don't think it's necessary. If there's any plastic, we'll see it melt off. Alright. Well, I smell something cooking and burning in there. Oh yeah. There's some, I don't know if you guys can see it, but there's, well, the heat shrink for one thing is gooey. There's also, maybe that's just goo from the heat shrink. Yeah, I was kind of wondering about this stuff. I was like, why are they putting heat shrink on a probe that's rated for 400 or 500 degrees? Yep. Okay. So, yeah, that's not going to work. Well, I'll take it off when I'll pull it out and cut that off, and we'll take a look at it. I'll take some pictures of it. I don't know if I'll film it. It won't be very interesting, but I'll take some pictures so we can look at what's inside there. But yeah, I figured this was going to be okay. I wasn't too sure what this was. I thought it was going to be some high temp heat shrink, but apparently not. Okay. Oh, we're not doing too good, are we? Okay, I got the last probe in there. It's kind of constructed like the one that we smoked, the Zal Best probe, except the Teflon coated braided wire, braided stainless, is smaller in diameter, and so are the conductors inside the wire. But it read pretty good. So I'll go ahead and stick this guy in there. Make sure he's not touching anything. All right. Go over here to the PC and let's get this over with. I'm slightly disappointed in how these things are turning out. The temperature is measured pretty good, but none of them are. It's like none of them are made for the oven, even though I specifically said it was for cooking. Okay, well, I'm back at the PC. I've been talking to the PC and I haven't been recording anything. Anyway, we started the Zenru test. So I've got the camera rolling on the oven. So let's just see how this performs. It should do okay. The Zalbest, it looks like it's constructed the same as the Zalbest. I guess as long as the heat shrink. Well, the heat shrink's only at the end on this one, so if it melts, I don't care. That's not going to be in the oven. It'll be plugged. It'll be by the controller. But I'm expecting this to do well with this test. All of them should do well with this test. Gosh, we're only getting it to. We're not even getting it to 400 degrees. Alright, looks like it's topped out again. Alright, go ahead and stop this and we'll take a look at it. Like I said, I expect this one to be okay. At least I hope it's okay. Let's see. Yeah, so the heat shrink on this back end right here, yeah, it didn't do so well, but that's okay. That's not near the probe side. That is yeah, the Teflon. It's not bad. It feels a little bit soft. I think this one did get a little bit hotter. It got almost, it's like 370 or something. So yeah, woo, ouch, that's hot. And let's see, look at the wires. Yeah, they did okay. So that's not a problem. Well, we'll cut this open and look at it, make sure at least this end of it's wired. This one's kind of nice. This one should be fairly watertight. Well, I'll show you later. I'll take a picture of it. But it's actually crimped over this casing right here, which should make it, you know, watertight, or at least it should be fairly watertight, if not completely watertight. I think they did say it was watertight, but I don't remember. That actually wasn't one of my requirements for it to be watertight, because a lot of these probes aren't. You just kind of wash the end of it off with some soap and water when you're done cooking with it, and don't bother soaking it in the sink, right? Okay, so what's the conclusion with with this testing? Well, I'll tell you what I did conclude is I'm not overly happy with the temperature range of the Teflon, and the reason why is Teflon starts having problems above 400 degrees Fahrenheit, and a lot of barbecues can reach 400 degrees Fahrenheit rather quickly, and some even go hotter than that. So I'd like to have something that at least would handle 500 degrees Fahrenheit. That to me would be ideal, because most barbecues, at least pellet grills, aren't going to go over 500 degrees. And so none of these probes, since they're all using Teflon, will be able to handle a 500 degree barbecue. I mean, they might for a short time, but not for any kind of a cook. So really, the only probe that actually passed quote-unquote smoke test. And we didn't even get above 400 degrees Fahrenheit, which is pretty sad actually, was the Zenru probe. And like I said, I'm still not happy with the Teflon performance at high temperatures. So I think what I'm going to do is I'm going to scrap all 4 of them and order new sample probes from all 4 manufacturers with stainless steel over fiberglass, where the stainless steel is not going to have this Teflon. It won't have any Teflon in it, and it's basically going to be exposed stainless steel, and then the wire sheathing or the wire insulation will be fiberglass, and fiberglass is good up to, I think, 600 degrees Fahrenheit. I don't remember. I'd have to check, but I'm going to ask all the probe manufacturers to redo them in fiberglass. And I'm also going to ask Zal Best to fix the wiring on theirs, because that was just wrong. And I'm guessing once they fix the wiring, it'll probably fix that 1 degree offset we saw, right? Okay. Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button, that really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.